Hello and welcome everyone. My name is Gökhan and I will present you our research of ARgent, a web-based augmented reality framework for dynamic content generation. So what's augmented reality? Let's start with a quick introduction. And augmented reality is an interactive experience that aims to enhance the objects in real world in real time by using feedbacks in form of vision, sound, and other forms. The AR mentioned in our scope is mobile AR, which is mostly about visual augmentation. So it basically puts 3D objects on top of real world to generate an augmented reality. As you can see on the left, there are virtual objects, and in the middle there is a real world, and when you combine these images, you get the augmented reality. The mobile augmented reality is available to most users by their smartphones and personal tablets, so it's being widely available. The applications of AR are in industries such as manufacturing industry, entertainment, healthcare, marketing, education, travel, and navigation. You can see that this is a factory, an industrial application. This is a game, so an entertainment application, an education application, and navigation. There are issues with AR development. First of all, AR development requires technical skills in multiple disciplines such as programming, designing, modeling, animation, and texturing. These are the same requirements for game development, but there is also the complexity of AR. And as a result, it's hard to find skilled people, and they are not easy to compensate. And there are a lack of dedicated tools for AR development. Mostly game engines are used for this purpose. And as a result of all of these, AR development is expensive. So what are our options for AR development? First of all, there are software development kits, also called SDKs. They are published by device manufacturers. For example, ARKit is published by Apple, which is the company responsible for iOS, and it works on iOS. So ARCore is working on Android, but some SDKs work on multiple platforms. They are called cross-platform compatible SDKs. For example, Vuforia works on most AR platforms. Then there are game engines. For example, Unity is using Vuforia to add AR compatibilities. And in its latest versions, Unreal Engine also added AR compatibility. Then there are authoring tools, which are dedicated tools for AR development. ARgent is one of them, and ARgent is built on top of Unity and Vuforia to enhance their features. So let's get into ARgent, how ARgent works and what it is. The data structure of ARgent is like this. So basically, ARgent consists of scenes. There are multiple scenes, and a scene is an AR context, and a scene consists of multiple objects, and each object is basically a visual representation of it and its animation. A visual representation of object can be a 3D model, a video, audio, or 2D image. So how a scene is created in ARgent? First of all, an asset, also known as visual representation, is uploaded or imported into the scene. You can choose to upload it into the scene, and it will be saved to database to be able to use it later. And in the next step, you can choose to get the asset from the database or get it from the file directly. And when In the next step, an animation is created for that object, and that's also saved into a database. The properties that are editable in an animation is its position, rotation, scale, and visibility. So an animation is basically a change of these properties over time. In the next step, uh, this is an optional step, and in this step, users can create scripts for an object and save them to database. Or also, a script is a behavior or UI depending on the needs of the user, and uh, these languages can be used for scripting. They are JavaScript and Lua are uh, very popular scripting frameworks for game development. And in the last step is uh, the data is fetched from database and showed in an AR-based application by combining the data with user input and sensor input. And an AR application can be shown in these three forms. It can be shown on marker, it can be shown on QR code, or can be shown on ground plane. So the architecture of ARgent is like this. There is a server, a web interface, and mobile application of ARgent. The server communicates with database, mobile application, and web interface. So it's basically a hub for all of these platforms that combines all of them. Let's start with mobile application. Its responsibilities are showing the augmented reality on top of marker and scene ID, fetching the data from ARgent Server, showing it in AR, and doing the user interaction. So there are three different rendering modes for an AR application. It can be an AR object can be shown on ground. A ground is a horizontal plane that's detected by the camera of the device, but it can be unstable as lighting conditions and other environmental conditions can affect the detection of ground. The AR object can be shown on a marker, but this is also not suitable for our application because you can show only one scene on top of a marker and it will always be the same scene. It will not be a dynamic scene. And the method ARgent uses is by adding a QR code inside a marker and showing different scenes depending on the QR code. So this is how the QR code for ARgent is generated. Firstly, there is the original marker without any QR code. Now there are two options to generate the QR code. We can put the QR code inside the marker or marker inside the QR code. We choose to do this approach because it utilizes the empty space by doing this. You can see here that there is an empty space and the device camera may not be able to detect this marker here because it will be smaller than this one. So this is an example of how the mobile application shows the AR. It detects the marker as seen here and QR code, and depending on the QR code it shows the scene. As you can see, there is an arrow and text here. Then there is the web application of ARgent. Its responsibilities are, it is firstly a content management system, and it's also managing the assets, and it's used for scene creation. So this is an example of asset management. In Asset Manager, you can upload file, upload a directory, or modify and delete the assets. You can see that there is a 3D asset here, and there are 2D assets. And this is the scene creation UI for web application. I will also show this in a video later. So basically, in this UI, there is an animation panel, the hierarchy panel, which shows the objects by their name. This panel is used for detailed modification of objects, and you can see objects on the scene as in 3D form. And this is the animation creation example. So an animation is created with the approach of keyframe animation. Basically, keyframe animation works by, for example, in 0 second, the object's position is this, and in 7 seconds, its position is this. So when moving through the timeline, object will move like this by interpolating its position and rotation over time. The last part of ARgent is its server. This is an important part which connects all the pieces of ARgent. Its responsibilities are providing a REST API for mobile and web application, persisting the data in database, and there is a method called asset bundling, which is very important for dynamically importing objects into the scene, because it optimizes the objects and packages them to be usable efficiently in mobile application and web application. How it increases the speed, and it has also other benefits. For example, the runtime parsing, which is compared to asset bundling, which is an alternative method, doesn't support as many file types as you can see on the asset bundling. So, for example, the FBX is a very important file type for 3D models, but it is not supported by runtime parsing. Also, you can see that none of the video options are supported with runtime parsing. So it's crucial that asset bundling is implemented. Then there is the loading speed comparison for runtime parsing and asset bundling. First of all, for small objects, runtime parsing can be fast, but it's always the same speed in initial loading and subsequent loadings. You can see that with asset bundling, the initial loading is slow, but every other loading is very fast because it will be cached already and can be used quickly. So let's see a scene creation demo of ARgent lastly. So this is the scene creation UI. I am adding an object to the scene. I added a car, and I am changing its size so that we can see it. Now I will create an animation for this object. I move the time indicator to 1, and I move the object with the move tool. Then I click add keyframe. Now I define an animation. It's that easy. And when you click the play button, it will preview the animation. Now I will change the loop mode to the reverse loop. Now animation will run indefinitely, but in reverse order. Now I can click the QR image to get the QR code and marker for this scene, and when I print this QR code out and show it to ARgent mobile application, it will show the scene I just created on top of the marker. And this is all for my presentation. Thank you all for listening, and have a nice day.